Luke Barrow, and today I'm going to be cooking, I'm going to be baking chocolate muffins, and I am going to also talk about and teach the different ingredients in them. So, if we take this baking soda, a base, and mix it with this milk and acid, then it will create a reaction and it will create a reaction that will leave carbon dioxide in the air, water, and salt. So we'll check on that later, because the milk is not a very acidic acid.
Next.
So the baking soda was a base, and the milk was an acid. And combining them created water, salt, and carbon dioxide.
What's next?
Next, I will be talking about some mixtures. So, an example of a mixture would be a suspension, which would be if we combine this water and some of this vinegar.
It's okay.
I'm gonna.
I already rinsed it.
Okay. No matter how much we stir it up, eventually it will separate into the water and the vinegar individually. And it's called a suspension because one of the substances will be suspended over the other.
We'll check on it later.
And we'll check on this later. Oh, it smells bad. Another example of a mixture would be the milk originally, and it's a colloid because like a suspension, it is not the same all over, or what we would call homogeneous, but it is different. It has chunks in it, but that doesn't suspend over the other. And milk would be a mixture of fat and water. Doesn't that sound delicious? An example of a solution would be this water mixed with some of this salt. And then if we mix it around, even if we didn't mix it around, it would still end out the same, but it would take longer. But if we mix it around, then we'll check on this later, but if we kept stirring it around, then it would faster. The salt would dissolve into the water and create a solution because the salt has dissolved into the water, and it's one mixture. So now for a compound, an example would be this water, because it is chemically combined different elements and and in some cases with compounds, most it would be different amounts of each, but for water, the compound is H2O, which is in each molecule 1 hydrogen atom and 2 oxygen atoms. And they're chemically combined, so it makes a compound because you can't separate them. So some elements we would commonly find in cooking are carbon, sodium, potassium, magnesium, calcium, oxygen, nitrogen, and hydrogen. Doesn't that sound delicious? So now, if I mix these all together...
Wait, let's check on them.
Let's check on these. So as you can see in the salt water, there is less salt visible than before, because the salt that you can't see has actually dissolved into the water and made the water look a bit cloudy. The milk and the milk and baking soda, there is less, it's slightly lower of a level of milk now, because some of it has combined with the baking soda, and hydrogen dioxide has gone into the air, and water and salt is also around in there, but it's not fully done yet. And if you look closely, if we just added some more, this might take longer for some reason, but eventually the vinegar and water will separate.
Are you sure?
That's how that works. So if we take these now,
I can't mix all this. Just put a little.
I'll put some of it in each of them. So if we mix these together now, it's now reacting. The milk and baking soda are now actually, I believe the vinegar and baking soda are reacting and creating water, salt, and carbon dioxide.
Now let's check out the muffins.
Now that we've mixed these all together, yum.